Hey everybody, and welcome back to another fun and exciting intermediate math class. Today we're going to be launching out into chapter number 4 in your books. Chapter number 4 is on page 142. On page 142, you see that this chapter is going to be about geometry. So in intermediate math, we're going to be doing algebra, arithmetic, geometry, all kinds of different things just to make sure that you know the basics for these before you go into the next levels of math. I've got a picture here, and in this picture, it shows several different angles, and I want to talk about how angles are all around you. Geometry is all around you. If you'll look here, I'll try to find a color that will actually show up on this thing. So here's a picture of some trees, and look here. Here's an angle inside of this tree. And you're going to see all over the place, you're going to see different angles. And if we keep looking, we can see other angles in the tree. All over the place, you're going to find things. Here's another one right over here. And you're going to find, we're going to learn about this today. I'm going to get rid of these. We're going to learn about this later today. These two lines right here, these two trees right here are called parallel. And so we have parallel lines right there. We have angles right there. We have all kinds of different geometrical shapes going on. Look at this bird here. You'll see that its wings make an angle. That's called an obtuse angle. We're going to learn about that in this chapter. Underneath, you have another angle right there. Um, if God didn't create birds with a certain angled wing, then it wouldn't be able to fly. If you've ever flown on an airplane before, when the plane has these things called flaps, and when the plane wants to go down, they extend the flaps. When the plane wants to, go up, then they turn the flaps the other way so that the air goes over a certain way so that it goes up. God knew all that before man ever had a clue, and God designed birds with these angles so that they could go up in the air and fly. And there's another one, and there's all kinds of shapes all around us. These bicycles, they have shapes in them. Obviously, we see a circle. All right, so there's circles there. Here's another angle right here. That's actually a triangle. You see it connect there. There's others. There's a shape right here. This is called a parallelogram, which we'll talk about as well. Over here with the pyramids, we have the triangle right there. It's three-dimensional, so that's actually called a pyramid. Um, this is something that's neat, and then they just kind of highlight the angle. So this is what's called a right angle at the top here. But there's also other angles. That's another angle right there. But check this out. Over here in the Sphinx head, there's also angles in the head of the Sphinx. Okay, and so those angles kind of make it look a certain way. And yeah, just angles everywhere and geometry everywhere. Here's the Leaning Tower of Pisa, and you see that it's got an angle to the ground. It's not straight. That's not a right angle. Most buildings are built on a straight. That building was actually built straight, but it kind of has tilted over the years. I had the privilege to go there when I was a kid, a little bit younger than you probably. I think I was in third or fourth grade when I went there, so I really enjoyed seeing that. I actually did not get to go up in the top because they don't let people up in the top because they're afraid it might fall over. So here you have a kite, right? And so the kite has an angle as well, and you see other angles down here in it as well. So all kinds of shapes all around us. So I just wanted to take just a couple minutes to show you those different angles kind of before we get started. Your book has a couple other ones. We see angles in our house. Doors are made of shapes. We have doorknobs that are circular. The door itself is rectangular. We have bridges and statues that are made out of angles and circles and all kinds of different things. So there's shapes, and geometry is all around you. In order to understand geometry better, we need to understand vocabulary about geometry. So in other words, when I'm talking about geometry, if you don't know the vocabulary, you're going to be like, I don't know what that means. He's saying things and I have no clue what he's saying. So let's start with the vocabulary. That way you'll understand, hopefully later on in the chapter when I start saying things, you'll go, oh, I know what that is, and I know what that is, and then you'll be able to understand the question, maybe on the quiz or the test, or you'll understand the video or the homework as I'm doing it. I would be remiss right here if I did not tell you about the guy that kind of developed or wrote the book on geometry. So his name was Euclid, and he lived many, many, many years ago. He lived before Christ, and he wrote the book, literally wrote the book. The name of the book is called Elements, and really all modern geometry textbooks are all based off of Euclid's work 2,000 plus years ago. And it's pretty neat. So, all of these words, all of these vocabulary words that I'm going to be talking about were vocabulary words. Now, Euclid didn't speak English, he spoke Greek. He was a Greek mathematician. So, obviously, these words have been translated, but all of these words are the same words that Euclid developed or Euclid used in his book, The Elements. So these words have been around for a long time, and in order to explain to his students how to do geometry, he had to teach them some vocabulary first. So that's what we're going to do first. Okay? The first word is the word point. Now, I'm not talking about like pointing at something. Okay? You're not using your finger to point. Maybe your parents have told you it's not polite to point. And so we don't want to point, especially at people, okay? Because people might think, we're pointing at them, and they might not like that. So we don't want to point at people. But that's not the point that we're talking about. We are talking about like a dot, okay? Now, it's not technically a dot, and I'll tell you why. Because notice it says this is an exact location in space that has, and this is important right here, has no length or width or depth. What does that mean? Well, it's kind of a theoretical thing. As soon as you put your pencil down on a piece of paper, you create what? A dot, a period, a point. Okay? There it is, a point. Now, as soon as you do that, technically, you have created length, width, and depth. Okay? Because your pen, when you put your pencil down, there we go, there's my dot right there. As soon as I put my pencil down, I created something that I could measure. I could measure that. I could take something, a micrometer, something, and I could measure that, and I could measure length. Well, Euclid said that points technically don't have a length, but in geometry, we have to write something. We have to be able to see something with our eyes. So to represent a point, we use a dot. We just put our pencil down and put a dot there, okay? So technically, we're not writing a point. We're writing a dot. We're writing a representation of a point. A point, in theory, is something that you can't even see. It's just an exact location. It's like, you're like kind of like right there. But as soon as you touch your paper with your pencil, you've created length, width, and depth. Hopefully you understand that. It's not that big of a deal, but I want you to understand the concept of a point. It's not necessarily the dot that we draw. That's just how we represent it. Okay? Next is a line. A line. Now, typically we think of a line as, okay, I'm just going to draw a line. Okay? That's not really a line. This is what we would call, this is down here, this is a line segment. A line, by definition, from Euclid, okay, in his book, The Elements, he said that this is a length extending in both directions indefinitely. So when we draw a line in geometry, we have to put an arrow on both ends of the line, okay? And those arrows, what those arrows do for us is they tell us that it keeps going in both directions. It just keeps going forever and ever in both directions. Okay. Now, we don't normally draw the arrows on the end of our lines. So what are we actually drawing? Okay. We're actually drawing a line segment right here. I'm going to come back to line in a second, but we're actually drawing a line segment. What is a line segment? It's a portion of the line with two endpoints. So in other words, it's like taking a line and we draw the line and then we put 2 points at the end. Remember, in order to represent a point, now a point, you could say that those have points on the end of them, right? Because points don't have space, length, or anything like that. But normally, so that we can see it, right? So that we can visualize it, we will put 2 points, 2 dots on the end of this. And obviously, our point has thickness and length, but okay, it's just a representation of the point. Okay, so a line has the arrows extending in both directions. A line segment is going to have dots or points on the end of each one. Now let's go back to the line for a second and notice it says it is made up of a collection of points. This is a Euclid thing right here. This is where he was kind of in theory saying what a line was. Now, we know that we put our pencil down. As soon as you put your pencil on the paper, you have created a dot, okay? So we put our pencil on the paper, there's our dot. And now what Euclid says is that if we keep putting our pencil down, we are going to create a line. And if we keep doing it, keep doing it, we're going to fill in that line, and pretty soon we're going to have a line. Now, when we draw a line, we just put our pencil down and we draw the line. Okay? We don't draw dot, 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 dot. But again, this is theory, and this is what Euclid said, so we have to learn it like he said it, because later on in geometry class especially, not necessarily here in pre-geometry, but when we get to geometry, you're going to need to know that, or else you're going to not understand some different concepts that he teaches. All right. Array. What is array? Array is when you take a point, okay? There's an endpoint, and then you take your line and you extend it in one direction, okay? Doesn't matter what direction it goes. So we're going to extend it in this direction. So notice on one side, we have a point, like a line segment, right? There was our line segment right there. So that looks like that. Then on the other side, we have the arrow, like our line. So it's almost like it's like a hybrid. It's half line segment, okay? And that's called array. That's not a guy's name, okay? That's maybe some of your names. Maybe your name is Ray. But this is not array like as in a guy's name. All right, next is the angle. And here's what an angle is. An angle is basically two rays that are connected at the same point. So if we take our point, let me draw a point right here, and then we take our ray, I'll change the color so you can see this. And there's one ray extending from the point, and here's another ray extending from the point. In any direction, it doesn't matter, you have an angle, okay? So I have a ray connected with a vertex. That's that word right there. That's the point. The common endpoint is called a vertex. It's an important word. You need to know it. So that's the vertex. And then you have another ray. So ray, vertex, ray. That is an angle. And I think most of you are probably familiar with an angle, but that's the name. So ray, that's that, and that's that. So there's two rays. And then there's the vertex right there. Okay. Next, intersecting lines. Intersecting lines. Those are lines that cross each other. So again, let's make sure that we remember what a line is. A line is indefinite in both, or it just keeps going in both directions. And then I'll change the color of the line and we'll put another line going this direction. Well, these lines crossed each other. They intersected at this point right here. Let's put a point right there, okay? So this point is actually called the vertex. And that should make sense, right? Because look, here's a ray, now here's a ray, there's an angle right there. Here's a ray, there's an angle up there. Look, we have 4 different angles. We actually have more than that, but here's 4 different angles for you to look at, all kind of like based on those intersecting lines. And so we would call that the vertex there in the middle where those 2 lines cross. Parallel lines are lines that never cross each other. So if we have one line here and we have one line here, those lines would keep going into infinity in both directions and they would never cross each other. Now, sometimes we have lines that are close to parallel, okay, but they're not parallel. Look at these lines. If we continue these lines, right, like if we stretch this line out and keep going, now I can't because I run out of paper, right? But if we keep going with these lines, pretty soon what's going to happen? They're going to cross somewhere. I don't know where over in the, in the next page if there was one, but they will cross each other. So be careful with parallel lines. They have to be exactly parallel. They can never touch each other, okay? And I don't know that my drawing's perfect, but it's close enough, so they will never touch each other. The last thing that I want to talk about in this video are these lines called perpendicular lines. So if I have one line, like kind of the other lines that we've been drawing, and then I have a line that intersects it or crosses it at what's called a 90-degree angle. What's a 90-degree angle? A 90-degree angle is like an L shaped. So it's like a right angle. That's what they call them, a right angle. I don't know why they don't call it a left angle, but they call it a right angle. Maybe it's a wrong angle, I don't know. But this is a right angle. So look right here, okay? Right where it crosses right here. Let me change the color so you can see it a little better. Okay, right here where it crosses, it forms an L, right? Yeah, and then it forms another L going this way, and then another L. It forms four L's, basically, or a plus sign, you want to call it, a T. You could use different letters or different things to illustrate what it's doing, but you have created a 90-degree angle. Now, the marking for that is kind of this little thing that we put right here like this. This would show that all of those angles are 90-degree angles. So make sure that you know that a right angle is a 90-degree angle. Well, that's all I have for you in this lesson. Hopefully you learned something. If you missed anything, make sure you slide it back, watch it again, review that. You have to know these basic words, this basic terminology in geometry, or else you won't be able to understand the lessons as we move forward. So make sure you know all these different pieces, these parts to the shapes. Make sure you know all about the vertex and the angles and the points and all that, because it's very important as we continue on through this chapter. All right, we'll see you later. That's all I have for you. See you later. Bye-bye.